Solve the following equations for the variable. So notice more logarithmic equations. The difference is, notice we don't have log equals log anymore, because not everything has a log. So in this case, this is where we have to use the definition of a log. All right, so remember, if you have a to the y equals x, then that implies that the log base a of x equals y. That double arrow there in the middle means if and only if. So if you're on the left-hand side, you can go to the right. If you're on the right-hand side, you go to the left. So if you remember the first couple examples we did in this section, we went back and forth between an exponent and a log. That's exactly what we do here. It is no different. C. Log base 3 of x equals 6. Notice our variable is trapped in a logarithm. There is no way we can solve for it unless we write it as an exponent. So we are on something that looks like the right-hand side of our argument here. So we need to make it look like an exponent. So what's the base of the logarithm in part C? 3 raised to the equals. What is 3 to the 6th?
729.
That's it, really?
Yeah.
That's nice. And you're done. Did you get x by itself? Yep. So one more time, part C. The x is trapped in a logarithm. We do not have log equals log, so we have to write it as an exponent. Use your definition of a log. And remember, the base of the log is always the base of the exponent. So part D, variables trapped in a log. We do not have log equals log. We have to write it as an exponent. So what's the base of the log? 5 raised to the equals. Nice tag team effort. Very good. Are we done? Do we have x equals number? No, so we just have to do a little bit of algebra. 5 squared, class, is 25. Good. So to solve for x, we'll add 1 and divide by 2. So if we added 1 and divided by 2, what do we get for x? What do we get? Oh yeah, we do, 13. Done. So please know the difference. If you have log equals log, set the arguments to be equal. If you don't have log equals log, write it as an exponent. Okay. Part E, solve for the variable. How is this one different from the previous ones? One more time? Well, how many logs do we have in the previous one? C and D. 1. And how many logs do we have here? 2. Well, in order to use that definition of a log, how many logs can we have? So we need to turn these 2 logs into 1 log. If we're adding logarithms, what do we do to the arguments? You multiply them. So that's your product rule. So if you add 2 logs, you can multiply the arguments. Okay? So we'll have log base 2 of, if we multiply those arguments, what do we get? 4x minus x squared. That black dot annoys me so. Oh no. There we go. There's a, looks like it has a mustache now.
How do we get to this x squared?
Sure. So since this is 2 terms here, you have to distribute that x through each one. So x times x makes the x squared. Is that okay? So the intermediate step there was log base 2 of x times the quantity 4 minus x. And that's the product rule. All right, variables trapped in the log. We do not have log equals log. What's a girl to do? Write it as an exponent. What's the base of the log? What's the base of the exponent? 2 to the equals. Good. What type of equation is this? It rhymes with quadratic. Quadratic. What we're going to do is we're going to get everything to one side and we're going to factor. So let's bring everything to the left-hand side. No, you know why? Because it's easier to make it's easier to factor with a leading coefficient that's positive. That's all. I know. All this work. Mike, you're a slave driver. I know. You're welcome. X squared minus 4x plus 4. How doth it factor?
X minus 2 to the second.
Very good. So if you set each factor where there's only one unique factor to 0, what do you get for x? X equals 2. If you put 2 back into the arguments, does it make any of them negative or 0? No. So is 2 okay? 2 is a good.